Hello everyone, welcome to my channel. Today we are going to see one of the best topics, that is ladder logic. Ladder logic is one of the top and popular programming languages in IEC 61131-3 standards because everyone is using the ladder logic. You know already there are 5 different languages used in IEC 61131-3 standards. Out of these 5 languages, 3 are graphical types languages, that is ladder logic, function block diagram and sequential flowchart, and remaining 2 are text based languages, that is structured text and instruction list. So we are going to see the best one like ladder logic as complete detailed and with examples, and we will see the complete basics. See, for the ladder logic is a programming language that represents a program by graphical diagram based on the circuit diagram of relay using the logic hardware. It is a primary used to develop the software for PLCs used in industrial control applications, and most of the people find it is easy and learn to easy and to get the complete knowledge in programming languages because this is easy and best for everyone. Okay, and we will see some of the rules for the ladder logic. That is, ladder logic or ladder diagram is inbuilt with the horizontal rungs with 2 vertical rails represent the electrical connections on relay logic system semantics, and you can program all the necessary input condition to affect the output condition, whether the logical or physical. And we can see that there is many advantages in this one because it is very easy, and the documentation also is very easily readable. And one of the disadvantage for this one is you cannot use for motion or batching programming languages. Here I am going to use the Siemens TIA portal for making the ladder logic. If you have any other softwares, example Schneider or Siemens or Rockwell, Delta, Omron, you can use any of the software. Because for me, I have currently opened this TIA portal. So we will check here. See, this one we already configured before the hardware configuration in the earlier tutorials. So we will continue with that same one. Double click the in the address blocks, double click add new block. It will take little bit time. Once it's opened, you can see here some of the blocks like organization, function block, functions and data block. Okay, here now for us I'm selecting the function. From the function you have ladder, function block diagram and SCL. So we are going to use the ladder. No? So I click I select the ladder, and you have option auto or manual. I will select automatic. Once I add, it is taking a little bit time to add the function of that new block. If you are using now currently for any other software, Sombra and Delta or anything, you can open parallelly with your software, because all the ladder logic, it is common functionality only. See, now I open this a function called block1, block_1. If you give the name before itself, you can give the same name. Otherwise you can just click the properties and you change the block name as per your wish. For currently I will put that because we are going to show now demo. Na? So I will put ladder_demo. And even from here also you can change the function from ladder logic to function block diagram directly. And this type is function type. And also you have some other informations here. See, you can put the author names, and also you can see the timestamps, compilation protections. You can protect this ladder logic here. See, now from here you have basic 5 function, normally like normally open, normally closed, and assignment, this coil or empty box, and also open branch and close branch. And also if you go to the right on the basic information instructions, you can find the same basic one in general. And from the bit of logic operation, you can find normally open, normally close, not, and also the coils, and also negative coil, and also reset, set, and also set bits, reset bits, and also see you can set bit field also, and reset bit field, set resets. This is like a flip flop, and also you can use positive, negative uh, bits and coils. And also if you go for the below, here you can find some other functionalities also. See the uh, first one you can use for a normally open, normally close, you can use for inputs, and output you can use the coils only. You cannot use the normally open or normally close contact for the output. Here you can see some timer functions also, like TP. uh, this is generate pulse and timer on, and also timer off. And you can see that upside is timer functions, and downside you can use for the output of the timers. See start timer, pulse timers, and timer on, timer off, the same function. Retain pulse and pulse timers also. This one we can see on the later sections, and also you can see the up counter, down counter, and up and down counters. And for the comparator operations, you can see equal to, less than or greater than, greater than or equal to, less than or equal to, greater than, less than, in range, out range, everything for comparison blocks. And also you can use the math functions like calculation, add, subtraction, multiplication, divisions, increment, decrement, minimum, maximum, square root, linear, expansions, sine, cos, tang. These all for mathematical operations. You can use many function of mathematics here. And also you have the move operations also. Here you can see the move, and also you can see some serialized, deserialized, move bulk, full bulk, gather, like this. And also you can see some variant also. And arrays, you can find lower and upper bounds of the arrays. Each functions we can see detailed on some other sections, because now we are going to see only the basics of ladder logics. Na? So, and if you see here for the other functions like jumps, label, switch, retain, and other functions here like runtime controls, NDs, and trigger, stop, all the functions. You have a lot of functions available in the Siemens TIA portal. And if you go for other products also, you have a lot of functions for the basic functions available in all the softwares, branded softwares, because they have standard libraries inbuilt with that software itself. And if you click particular functions, you can go to the help, you can find the complete detail of the each functions. But later on I will explain the timers, counters, comparators, max, calculation, moves, and other operators. But now in current section we will go to now to check the basics of the ladder logic. So we will go how to use the ladder logic, because it is one of the easiest functions. And also you can see here downside, and or, XOR, invert, and also selection, multiplex, demultiplex, and shift right, shift left, rotate right, rotate left. All the functions available in the basic instructions. And this is the one of the, this library is only the basic. But if you need to go for further libraries, you have a lot of additional functions also, like scalings and other like communication blocks and everything. It is available inside. But now what we see is only the basic. Okay, so the basic instructions, you have a lot of functions. See, if you go for extra other instructions, you have a lot of functions inside, because it cannot be covered in one or two sessions. It will take lot of sessions to complete all the instructions. But for current situation for us, we are going to use in the network one to add some small logics. This is the left rail and you can use up to the right. Once the left rail is completed, then only the logics will move to the second rank, because you have continuous ranks. Na? From the left rank, it will check if the all the conditions are satisfied, it will go until the right. If it is not satisfied, immediately it will move to the second rank. So before that, just we will open this one of the example what we are going to do now. This is one of the pump control logic. From here you can see there is a remote through the SCADA, and you have auto function, auto selector switch, and this is a function which we are using for motor control. So we will use the same ladder logics. We will make this one into ladder logic now. And you have push button, start and stop push button, and if you go downside, still you have temperature fault, moisture fault, and once it's satisfied all the conditions, then it will start the pump. And after that you have overload relay also. And this function of K1, the contractor, be taken to the push button of the start button. And also you have the auto, you have some selector switch for auto. Now what we will do now, we will take this same pump control and we will make in the ladder logic, because the ladder logic is based on the relay control logics. Na? So we will use this relay control logic now for our example, and we will make this one. See, now first we need to note down this all the ladder logic. See, take your time and you can first think how to make the ladder logic, then after that continue this video. Okay, then you can understand what we are going to add there. So now what I will do now, I need to be add the complete before adding the logics, I need to add the data blocks. Okay, so see, just if I drag and drop these normally open, you can add directly. See, from here already I created before, na? That one we can use the logic. But what I will do now, I will add new database for this one. Just I will try to enter here directly, but it will give us error, because pump one underscore remote, it is not available before, so it is giving us red color. What I will do now, before I am adding this one, I will create a new database for us. For that one, I will double click the add new block. See, here you have the last function called data block. From here I will add this data block. I will keep the same name like block underscore one, and I will use here ladder, like see this one, actually block data block, it is global block. Just I will add that one. Once you add, this page will open for entering all the data blocks. For the first one I will add the same pump on underscore remote, and default it will come boolean. I will keep the same boolean. Then I will add pump one underscore auto, because in our in our logic diagram, we have pump on remote, pump on auto, and pump on manual. So I will add all the digital input signals, and also I have pump on underscore. I will add pump on underscore start command. Str underscore SCADA come. Better I will give the pump on start push button, na, there. Instead of that one, I will give here pump on underscore start from SCADA. Okay, start command from the SCADA. So, and I will give similarly pump 1 underscore stop from SCADA. You can create by yourself what you need, that what are the tags you need. For me, I will use the same of that relay logic diagram, and I will add here pump 1 underscore temperature fault, and I will add one more pump 1 underscore moisture fault, and pump 1 underscore overload relay. No, that is the last one, overload relay. And the next one I will give like pump 1 underscore, this is the start command. I will give start command. This is the DO. Remaining all, it is the DI for, because if all the conditions it is satisfied, then the start command will start. This is our single line diagram or relay logic diagram. No? So we will follow the similar to that. So I will add here, see in the data, here I will find here the data block, because the name called data block. No? Inside data block you added all the functions. So I will add here, see first I will add remote. This is from the selector switch from the MCC panel or relay control panel. So I will add that one, and then I will select and give the normally open contact, and I will add again pump 1 like pump 1 underscore auto. Again I will add here one more function, or like one more normally open contact. This one I will give pump 1 start command from SCADA. This one just I am giving some examples for your understanding purpose. Okay, this logic. So you can add here pump 1, and just I will go back, because I will add for start command from SCADA. And later on I will show you the standard blocks, how to create the standard block in the function, like in the function block also, and that blocks you can use in many places. But now this is the basic class, no? So I will teach you how to make the basic language for the ladder logic, and here I can use pump 1, because now I am going to use the normally close contact, no? Because it should be, this remote should be open, auto should be open, and pump start should be there, and there should be no fault, no moisture fault, and I will give you there should be no temperature fault. So I will select that temperature fault signal also, overload relay, and also I need to be add temperature also now. Add data block and give, just click there, because sometimes it will show you, if you not click directly it will show you some error. Red color means you need to, there is some error. So you see, now I will add pump 1 temperature fault. See, this will be continue, this arrow mark will be continue until you will close, you will make the command end. See, now I will add that normally like coil, I will use normally open coil. See, here I will add pump start command, the data block again. See, again I will go here data block, and add the start command. Now I make one complete logic of one relay logic, that one which we used in the drawing. But here for the command you can use direct command, but this one what it will happen whenever you are example, if you given start command, if it is not latched, the command will be not run, because otherwise you need to make a feedback of that command. That command you need to take as a feedback. But what I will do, instead of uh, making the latch in the normally open contacts from here, see, because I will just, in case if you are using in the SCADA by like a momentary switch, at the time it will not work. If you use latch, it will work in this logic. For that one, what I will do now, I will add, instead of normal coil, I will use a set reset coil. See here. Okay. What I will do, I will take this set and I will use in this place. See, when I drag and I will add here, see, it's already added. I will copy that same command. I will remove that normally open contact. See, even sometimes if it is copied, if the system is slow, it will copy 2-3 times. So you need to be careful for that and remove that normally open contact. And also you can remove the another set which we use as additional. See, now you already closed one complete network, because now you already added, there is remote, auto, and start command from SCADA, no trips, false, and it will start the pump. Now I need to stop the pump. For that one, what I will do, I will take the pump, the remote, there should be no remote and there should be no auto. Otherwise, you can also, you can see, now I will take normally close contract. Okay, you can take either, or you can take from the basic instruction, and you can add the same functions like there should be no remote. The pump should, if there is no remote, the pump will be off automatically. And also I will take again, because you cannot do everything this in series, you need to make here as parallel, because any one of the condition is not satisfied, the pump should be off, no? So you need to put everything in parallel, not by series. Series means if all conditions should be satisfied, example, there will be no remote, again it will check another function, and moisture, there will be no fault from the moisture or relay or anything. So it will be parallel, not series. So I will add here that the pump, otherwise the pump stop command from the SCADA, or I will add again. See here, I will add, there will be any moisture fault, because here you need to use normally open contact, because now this fault should be in the first logic, there will be no fault, but here if there is any fault, it should be operated. Now here you can close that block. See here, this option you can take and close your logic first. You can follow this exercise along with me, so you can understand completely what you are doing. If you have any mistakes, you can ping in the comments, so I will check and I will inform you what you, like example, you have some issues while doing this application, just message to me in the comment. So now I am taking for this pump fault and add here as pump fault, and add this close this rung. See, now if any one of the rung, like the pump is not in remote and the the pump stop command. And also I will add one more function for the temperature, moisture and overload. See, now I added all in parallel, and here I am going to add reset button for this, for the pump. See, just drag and drop, it will add automatically. So here you can select and or you can copy that start command and you can copy paste here. Otherwise you can select from the data block, like inside browse and select your particular data, example pump underscore start command. See, you can use either start and stop commands separately, or you can use one command for start and stop both. Okay, now I added these both logics. See, now I need to be check whether there is any error. So I need to compile this application. See, I can make a little bit big, small, because it is going out. So I will use 80%. You can make the zoom in and out in the downside. See here, I already added. So you can see here. See, in the online you have a lot of functionalities. You can see in my previous exercise. You can understand what is the basics of what is the function of each one. And I will save this application, and I will compile this application. See, you can see in the right side it is saved successfully. Then after that I will compile and I will download to the simulator. See, now I will just software changes only. Now I made it. So I will compile. If there is any error, you can find here directly. But now in my case there is no error, so I load this one. So it's loading completed successfully without any error. So I will start my simulator. If you press run, it will go directly to the run mode. Still I did not find it is in the run mode, but what I will do now, I will check, because I already have another simulator. See, it is already running. Okay, so I will close that one and I will open this simulator. See, now already it is running. See, now you have option to download, upload and simulation and run mode. Okay, so I will just try to download this application. See, it is trying to download now. See, simulation mode, and it is online update. See, when I try to download, just press the load button. Before, if you need to see the error, you can find what is exactly the configuration is up to date. So I don't need to download again because it's already up to date. So I will run the application. See, I will I am just monitoring now. See, now I did not get any values because everything is connected to the PLC, and it is simulator is connected, everything is right. But why my values is not coming? Because I already explained in the first section. If you are using Siemens TIE or Semantic Manager, your function, you created new function. This function should be connected with your main function block, operational block. See, therefore I did not connected here, therefore it's not uh, running. See, I am just trying to monitor, but I did not able to monitor, and the function, this logic is also not working for me. See, I did not able to monitor online monitor for this logic. So what I will do now, this function, see, this ladder demo, this function is not linked with main or organization block 1. Okay, so for that what I will do now, I need to link this one to OB1. Okay, for this here, I will double click the OB1 now. But if you use for other Schneider Unity Pro or others, you don't need to require to add in the main block. But here in Siemens, you have to add in the main block. See, already I created before for pump, now functions. But here I did not add it here, so it is not running. So in the network 3 now, I am going to add this main block. See, once you do some modification, it will automatically come to you. There is some modification happen. So this one, if you done some modification, again you need to recompile the application. See, now I am going to add the function. See here, what I will do, instead of adding from the function, you can drag and drop the function here directly. See what I will do now, I will take the ladder demo and I will drop here in the network 3. See, it's added automatically. Okay, this means in the main OB1 you already added your ladder logic now. Now just compile the application again. See, now you added your like you compiled your application. It is still, it's compiled, and download software to device is ready. You need to just load. Once you press the load, it will be automatically loading, I think, completed with 0 error and 0 warning. See, now the block, it's become green color. This means it's already compiled. You downloaded to the simulator, and now I will check now in the ladder demo. I'm going to make monitor now. See, now everything is in green. This means it's okay. Here just monitor the signal now. See, now you are monitoring clearly. So what I will do now, I will run one by one. Like now you can think that now you are in the MCC panel. You are going to put the remote button. Just I will give one. This means, see, now with the green, it's come up to here. And now I'm going to give auto command. But if you add the physical signal, it will be automatically on one by one. But now in my case, I'm just give directly to here to add one by one. See, now I given start command. See, once I given start command, it started directly. The pumps is started. Okay. So if you see here, the reset, because it's this function also stop button, I given wrongly, like because it's normally open, suppose. But here already it started. So what I will do now, I will make a reset from here. See, just click. Before that, just make a little bit small to monitor the start command also. Okay. Now I will give some trip signal. See, once I give trip signal, see, it stopped the pump. This means your ladder logic, what you made, is correct. You can start and stop based on your input and outputs. So this is the basic function how to create the small ladder logic. On in next coming sections we can make a depth ladder logics, and we can see some detailed one, but this is for the beginners and who is interested to learn the automation as a beginning. You can this video will be useful for them. See here, you can see here the I am using this simulator to run this complete logics. Similarly, you can create your own logics and you can make a demonstration and check if it is working or not. Check one by one functions what you have in the basic instructions. You can use the functions and check one by one, so you can understand how to create the logics. And you can take some samples, example any one of the drawings, and make as per that, or based on your control philosophy you can do your logic. So I hope you enjoy this video. This video will be useful for basic for beginners, and soon I will add this another topics for timers and counters. At the time I will explain detail about the what is on timer, off timer, what is retain, pulse timers, and count up, count down, and other functions also. Thank you for watching this video. If you like this video, press the like button, subscribe, and share to your friends. Thank you.